Yeah, sorry. Good afternoon, everyone. Actually, we had some issue in recording the session, so we got delayed. So I welcome you all to this session on applications of Google Earth Engine. And today we will be having the session on water quality mapping and change detection. Our guest faculty today is Sri Ameya. Uh, he is an expert in remote sensing and GIS field, and he's acting as a consultant for many projects. And he's associated with many projects taken up by state governments. He has done his master's in remote sensing from ITC University of Twente, Netherlands. I would now like to invite Mr. Ameya to please deliver the today's session. Thank you.
Thank you, sir. May I start?
Yeah, please start. You can share
I'll
your
share.
yeah.
Good afternoon, everyone. My name is Ameya Gode, and today I'm going to conduct a demo and training on the topic of water quality mapping and change detection using Google Earth Engine. So here we'll be trying to address the question that can we use this cloud-based processing, the ML algorithms, big data to get what we want, the water quality of the entirety of India's water bodies. So let's start with the first question, that why should we have this kind of water quality assessment? So, sorry, please. Yeah. So almost 80% of India's surface water is polluted, according to a paper published in Elsevier some years ago. An alarming percentage of groundwater reserves are also contaminated by various organic and inorganic pollutants. So here the problem is that in India, of course, we have a large population, and the population is distributed uniformly geographically all across the landmass. Because of which, then we have thousands of water bodies, but there is a large number of population which is dependent on each water body. So if I give the example of Pune city itself, there's a population of 70 lakhs, and five major reservoirs provide water to this city. So that still makes about 14 lakh people dependent on one reservoir. So, given the amount of population of dependent, it is necessary to monitor the water quality of each water body the year round of each water body. That is why this is a very pressing topic in India, and it's going to get more and more pressing in the future. So what is the current scenario of water quality? So the Central Water Commission has been monitoring water quality since 1950. They have 519 water quality sites at present, 33 water quality monitoring stations across India. Additionally, there are 295 level 1 laboratories, 18 level 2 and 5 level 3 laboratories, which are conducting analysis of 25 water quality parameters. Which brings us to the problem statement, that why do we have to go to satellite? So first of all, we are using sensors. Currently, the best the sensors are being used for monitoring water quality. So this is point based information. In a GIS sense, this is point data. So you've got information pertaining to only that latitude and longitude. Secondly, sensor-based water quality monitoring needs mobilization of personnel and equipment, the costs involved in it, the maintenance, and so on. The coverage is, again, the most important fact is that the coverage is limited to sensor location. So anywhere you want to assess the water quality, you have to place a network of sensors, because you can't do it a single one in large water bodies or rivers. So here we have to look for something that will give an all covering a large coverage map. So each water body, every inch of each water body, we need to know the water quality. Then we have to turn to remote sensing. So for decades, remote sensing has been used in the field of water management, of course. Google, the current course also is a good example of that. So coverage, transparency, and reproducibility. The satellite images cover every inch of the Earth's surface, of course. By transparency and reproducibility, I mean that the algorithms that we'll be using today can be used by any of you for your own areas, and similar results can be obtained, comparable results can be obtained. So this is the reproducibility I'm talking about, that which make remote sensing a highly efficient monitoring system. And then cloud-based processing, of course, there's no need to say that a few years ago we were downloading one single image of 70 by 70 kilometers and processing it for hours when we could get any results. But now you can pull an entire India false color composite within seconds. You can download it, you can use it. So basically, it is revolutionizing the remote sensing world. Massive analysis is done in seconds, and we are trying to make full use of this cloud-based processing, which is Google Earth Engine in this case. So let's come to the main topic of remote sensing of water quality. So there are several scientific studies. Maybe some of you might have done some research that there are several studies which have been published all around the world. The various water quality parameters have been mapped using satellite images. What you need is the ground truth measured by sensors, which is fairly distributed geographically, and then you have to do your own analysis. You can build a machine learning algorithm to predict the relation between specific multispectral bands and the water quality parameters. So with this ground truth data, it is possible to map these parameters at high resolution, 10 meters. You could even map them at 50 centimeters using commercial imagery, of course. But here on Google Earth Engine, we are going to use the freely available Sentinel-2 10-meter imagery. So here we have tested the applicability of calculating the TDS, total dissolved solids, using the existing algorithm, which is a paper published in France. So in a French lake, they have tried to estimate this water quality. So we use some data provided by the Central Water Commission, of course, to tally the results. And the experimentation is still going on at more sites to get a perfect idea. But using Google Earth Engine and ground truth information, it is possible to set up a continuous monitoring network for water quality. So here now I'll come back to, now we can go to the demo, then I'll come back to the results and discussion. So I will start the demo of how do we. Here we have the code ready. So we open the Google Earth Engine code editor. So let's take an example of our large water body, say this one. As I mark my polygon over this water body, the variable is inserted, geometry. So here we are going to give Landsat. I'll go through the code one by one first, and then later we'll run it and see how the water quality results appear. So we define Landsat and Sentinel. Here we have the start dates and end dates. So between these dates, it will look for the imagery. The cloud, we have kept it at 20% maximum. Here the selector case, we've kept it to select between Sentinel and Landsat as per the user's convenience and the date. So because many a times you would need an image of a very specific date. So it is good to have the option of both satellite constellations. So here we have the Sentinel image collection. Then we filter it using the cloudy pixel percentage. We need the least cloudiest image first. We filtered the date with the start date and end date that we defined earlier, and the geometry, which is the extent that we marked. Similarly, for Landsat, we have the same lines of code. So then here the formula, this formula was for this. So here the thing with formula before I start that this is not, okay, this cannot be considered as a one-stop solution formula to estimate this matter anywhere in the, so you have to do the own experiments using the ground truth data. So here we have near infrared and green. You can see the formula NIR by green plus 0.7878 divided by 0.2577. So this is supposed to give us the particulate matter in milligrams per meter cube, so micrograms per meter cube, pardon me. And so here we have the return, the SPM, we are calling the, let's call the raster as SPM. Then we plot it, of course, we give the parameters, we give the colors. Optionally, we can keep an export also if any of you want to visualize in your own GIS software, you want to perform your analysis, we can keep an export option also. And now I click run. So here you can start, you can see that we have started getting the results. I will tweak the values here a little bit because we don't have such a high concentration of SPM in here. So yes, now when we visualize this, now I can emphasize upon the importance of having satellite based assessment, that here you can see the plumes of the particulate matter in the water. You can see where it is coming from. You can see where the highest concentration of it is. So even within one water body, without placing several sensors, you have the water quality of each and every corner. For example, you can see here you have the highest concentration of this suspended particulate matter. So similarly, this process can be applied for rivers. The plumes can be detected. Various automations can be. So, here, for example, you can detect that a lot of suspended matter is coming from this end. So for many areas, I've heard in the last couple of months that they want to simply prove that there is suspended particulate, there is some particulate matter being discharged by someone, say some other party. But for the past data, we cannot present any proof unless it is happening right now. But here is your proof, here is your solution to, you can go back in time or even forward in time. If any sort of particulate matter is released into the water, you can detect it. And of course, for the last few days, you have been assessing Google Earth Engine, so you know that there's no limit to it. I can do it for the entire state, I can do it for the entire country. So this is an inland reservoir. We could also give a try for coastal, because for many a times coastal suspended matter also might be. So let's go the Chennai side and we'll run the same algorithm. Sorry, the image is big. Now still we still managed to get a fairly cloudy image. So again, I'll tweak the upper values a little bit. So this visualization is important for if you want to detect plumes. And so here in the inspector tab, you can even get the actual value. So wherever you click here 31, wherever you click, you get the actual value. So I'll just a little bit. Yeah. So here now you can see in the coastal region, you can very clearly see all the patterns of the suspended sediments which are in the water. You can see the highest concentration of suspended sediments. And logically, now we don't have the field data here, but you can using logic that near all the land masses, you've got a higher solution of suspended sediments. So this algorithm can be applied in various areas. This can be used to monitor water quality. All it is a matter of is the changing the date. So you can set up a monitoring network, say twice a month or once a month. You can monitor all the suspended sediments in the water, their quantity, their direction, where they are coming from, where they are going, which are the people affected. So these kind of, I mean, this is all in the PostGIS. So I will also, this is the demonstration. Now I'll go back uh, to my presentation just for the last results and discussion part, which brings us back to this, that the plumes of pollutants, the origin of pollutant, the population affected. Then you can have automated alerts to the concerned officer at real-time basis. They can get an SMS from the portal that some sort of pollution is observed by satellite, and on a large scale. So for us, for example, for a state at a centralized location, you can have a portal where officers can sign in according to their position. They can view within their jurisdiction the water quality of every water body, because we have 10-meter resolution data here. So and then they can take the action. They can be notified any within their area. These are the most polluted lakes, and all of this is in real time. So every 2 weeks, for example, they are getting an alert that this lake is polluted. Especially because we hear in the news many times that, for example, in Delhi, above the Yamuna, you have started seeing this white foam. This can have this is something that we just see in photographs or something that a reporter reports. But what if we were monitoring every single satellite image over all those states from which the Yamuna River flows? Then we can get an exact extent of that white foam. How much is it? Where is it originating? Where does it end? So probably these things can be used to make informed decisions in the future. And with the increased repeatability of satellites, of course, it is possible to monitor any sudden changes. You've got Sentinel-2 A, B, and C. Then you've got Landsat 8, Landsat 9 is just been launched. So this is just going to get better. Right now, if I go to Sentinel Playground and try to check for imagery, I've got one almost every 3 to 5 days, which is not bad. If every 3 to 5 days you are getting an update, so let's say practically every week at least, considering the cloud cover and other things, you can have a water quality assessment. So this brings me to the end of the presentation. Please give me a moment while I show the last final. Yes. So now, which brings us to the that Google Earth Engine can, of course, there are various other cloud-based processing options. Amazon Web Services, you have Synapse, various other options by which you can set up your own portal on your own website. Because I understand that this has to go on the government servers. This data needs to go on the government servers. It needs to integrate with other types of vector data, for example, point data, and then a centralized solution can be made by which this monitoring. So what I have been talking about for the last 2 minutes, this centralized monitoring solution. I'll show a small example. This is not some official portal or anything. This is just a sample portal that we have made to show as an example. So this is this is Kanpur. This is the Ganga River flowing through Kanpur. So here we have the suspended solids and we have the dissolved organic carbon. So here, because at this very point we have a CWC monitoring station, so we can even verify that whether the results we are getting from these satellite images are correct or not. So I just go here and I select the month, and within the Ganga River, you can start seeing the suspended sediment, suspended solid concentration. So here, maybe right now, even we have the ground truth for this point itself, that this is the only data that we have. But now you can see that we can monitor the entire Ganga River from here. So maybe if someone is familiar with this region, they can verify also that towards this end, But here you can see these delta towards this end, you have got a much higher sediment concentration. As we come towards the Kanpur barrage, near the barrage, you've got the lowest con. When you click on any pixel, you get the value of the suspended sediment. So here near the barrage, you've got the lowest ones. So here even the values I won't say they don't matter, but more importantly, it is the location which is showing that now we've got within the Ganga, every location that has suspended sediment problem, we can monitor it every week of the year. And again, as I said, this can be used to make informed decisions in the future. Again, other than suspended solids, we also have dissolved organic carbon. So this also similarly, we can have a map of this. It will start showing the dissolved organic carbon. There are so currently established formula you have for suspended solids, dissolved organic carbon. You have then anything related to photosynthesis, which is algal blooms, photosynthetic activity. These can be monitored. pH can be today on the WhatsApp group. I read a question that can pH be monitored? If you give me at least 10 points of pH with location and the period, we can very easily build a regression equation because we've got Earth Engine. The code won't be this anymore, but rather I'll extract all the values for that time of all the 12 bands within Sentinel-2. Then I'll extract the principal components analysis of those 12 bands, any other indices that I can, to see which one of them, which one or combination of them can be used to predict the pH most accurately. Then we test it again with the data. So this is an open-ended subject here that I'm talking. You can go up to any level to estimate these water quality parameters. It is up to you that how much ground truth data you have. But the best thing here is that once you establish this relationship between the pixel values and the actual real world pollutant units, then you can keep on monitoring it into the future. You can monitor it weekly, bi-weekly, monthly. So this is a one-time thing to use the sensor-based data, and then these are the results you can get. Many other features can be added here. For example, if a plume has come here, the officer who is in charge of this very area of the Ganga can be notified by SMS, by WhatsApp of the location with lat long that there is a plume originating from this XY location. So many, and again, of course, I have very little, of course, the participants can think of many other applications of this in their own fields, in their own areas. So this is a very interesting thing that we've got here, and this has the potential to monitor the water quality. We need to keep on monitoring on a large scale, and we need to monitor everything, most importantly. That this algorithm is going to give every small lake, and right now I have only kept it to the Ganga, but this can monitor every water body present, which is the need of the hour. That not just the major water bodies and rivers, but every water body in the country we have to monitor. This cannot be done physically. We cannot place sensors in every water body. So this could be the way ahead. Uh, so with this, I would like to end the water quality presentation, and then I would like to come to the last part, which is change detection. So now it might sound a bit that why change detection? Why do we need to detect changes? Because any land cover changes are directly related to water quality if you think of it. So this may include landslides, this may include encroachments, rock falls, this may include industrial activity, sand mining, all anything that changes the earth's topography. Till now we would have a, so I'm going to show a code on Earth Engine with which you can detect all of these kind of changes which happen. So in the riverbed, for example, you can check for encroachments in the riverbed, you can check for illegal sand mining using this, you can check for constructions. Again, in your own fields you can think of even more applications, but this is something that will affect the water quality, or rather it will affect the water body in some manner. So it is necessary to even keep a watch on the land cover around these water bodies. There could be deforestation. So let's go to that demo. So I'll just quickly show a demo of how do we detect changes. So here now, again, one more thing I would like to mention that now please explore some of these apps. Of course, it is good that learning Earth Engine, you can make your own scripts, but it is also good that you join some Google groups, some social media groups of Earth Engine, and there are so many ready-made scripts that people have made, scripts with 1500 to 2000 lines, which are extremely useful and all open source. Since Google Earth Engine is open source, these things are also open source. So for example, this is a script called Sirad, which has been used to monitor deforestation in the Amazon. So, and this uses Sentinel-1 radar, so you've got no problem of cloud cover. So every 15 days, every 7 days, you can get an account of any change that has happened. So let's here actually, and one thing that I should have mentioned even earlier, that now if you want me to quickly conduct a demo in your area, there is especially something with high suspended sediments, some water body, please put it in the message board right now. I'll conduct it in the live session, that I'll go to Google that area in Earth Engine, and I'll show you a suspended sediment map of the water body that you wish to. Or even if you've heard of some sand mining, some landslides, some change that has happened in the area, please notify me here. I'll immediately. So for now, on 22nd of July, there was a landslide on Castle Rock near the Dudhsagar waterfalls in Karnataka Goa border. So this we use as a ground truth because this is something that I know for a fact that this had happened. And then here we'll just, so this is the script. So this is not your regular Earth Engine code editor. This is a UI that someone has already created. You don't need to do much here. So this is unfortunately the guidelines are in Portuguese. So here I just put 3 dates, that these between these 3 dates, please show me every change that has happened. So here I'll be using the VH polarization, as is the case for flood mapping also. And so here your radar images have opened, the post event image. So here the grays you can see are the areas with no change. But we want to see the areas where change has happened. So now we go near this area. According to the news, landslides had happened. So here you can already see in this sonolim, it had fallen onto the railway track. Maybe if my screen is loading for, you can see the railway track going from here, and the colors suggest the areas where the landslides have happened. So even these other areas, if you see now here, you can see some red patches. Uh, So please, yeah, let me first. These are the landslides where you can see the colors. This is where the landslides have happened. Similarly, all kinds of changes you can detect. So here, for example, this is some village within the forest where the harvesting has happened. So this minute level changes you can keep on monitoring. Here near the river, you can see that some changes have happened again. So this kind of monitoring, again, this is one another kind of monitoring where you're monitoring the land. And again, the water body also, you can have the water area, exact water area. So this is another good factor here, because otherwise you're aware that we have the cloud cover limit. Not do it every week, but with radar images, you don't have to worry about clouds, and you can do uh, up that the possible many manpower. So there's endless experimentation that can be algorithms parameter. And one question actually, because again on the WhatsApp group, I had read the heavy metal concentrations in the water. So here I need to say, unfortunately, because heavy metals are present in extremely low amounts in surface water, minuscule amounts, which cannot be really detected. I mean, they don't really stand out as just suspended sediments. So here I would like to say that there is another way that you can find out this from the crops. There have been studies finding lead, cadmium, arsenic concentration in crops using satellite images. So this can be done. If you tell me some area where you know for a fact that there is heavy arsenic contamination, I can find out the start date and I can establish a relation between the images and the crops affected by arsenic. And so again, like I said, the possibilities are endless. You can even for some side viewing, you can also go to SEN for WAC, which is Sentinel for Water Quality. It has been sorry. Sorry, it's not, it's say 2 WAC, Sentinel-2 water quality. So here you have some custom scripts. You can even visualize it or you can have the scripts for yourself. This is not, however, Google Earth Engine, I must tell, but this is again a product of cloud-based image processing where you've got 6 water quality parameters. I'll also show which 6 are those. So here you have chlorophyll A, here you have cyanobacteria, turbidity, chemically dissolved organic matter, DOC, and color. So these parameters they are showing all around the world on a weekly basis. They've got this custom script of their own, and they show it for the entire world. So this is the kind of power of cloud-based image processing. You can of course explore this say2WAC on your own. You can even do these experiments on your own for these water quality parameters in your own areas. Which brings me to the end of this presentation. Thank you very much. Okay, so now I have a few requests. So please, uh, here we have. Please let me answer a few questions here. So iron calcium carbonates has been there's a question where again if you have the water quality data, if you even a yes or no confirmation that this is the location where you have specifically a high carbonate concentration, then we can make our own study. There are several existing studies too, but again since this is an implementation based thing, we have to verify with our own data in India also. So I'll just few of these. So Ghataprabha River near Hidkal Dam. Yes, so I'll be showing. So as per we need the Ghataprabha River, Hidkal Dam. So we'll just check it here. So this is the Hidkal Dam. There was a request in the message board that this one should be analyzed. So you have to look for the best combination. So here, yeah, you can see this dam. Maybe you can verify whether this is true. I mean, not from the values, but at least from the visualization that here you have at this end, you have the maximum concentration of suspended sediments. Towards the dam side, it gradually, but then you've got a few. So these are the green ones are cloud. Sorry. Oh no, no, these are land masses. But so here you can get the this SPM concentration. If any other, Sorry.
Can we go to the mouth of any river and see the
Yes,
sediments?
here I think there was one river Hooghly near Palta, West Bengal. I think that is, or we can just go to the in West Bengal. We can go to the seaside.
Your sharing is off.
Oh, sorry, sorry, sorry. I'll just. Yes. Here it's okay. Here I'll run one example. There. So these are again clouds. We have to do something about the cloud cover. So please ignore this part. But near the mouth of the river, if you can see, you have the suspended sediment values of each pixel. You can observe the patterns. You can observe these are again. I should reduce this script needs a bit of editing actually. We have to lower our cloud limit. But for the non-cloudy areas, you can already see the suspended sediments in the water. Near the land masses, you have a higher concentration. Uh, any other?
So, Mr. Ameya, the established relations are available for which parameters, water quality parameters? Can you tell
Uh,
us?
Sir, established are for of course, the suspended particulate matter. You have the chemical oxygen demand. You have any of the biological ones, such as the cyanobacteria. You have photosynthetic activity. You have algal blooms. So these three are extremely established. These ones. Then the color, turbidity, and as I said, I mean we can keep on experimenting with new water quality parameters, and we can keep on coming with. So just like NDVI, that one fine day someone found out a relation between near infrared and red, that it relates to vegetation health. So similarly, like that, we've got so much ground truth data, we've got large water bodies, we can also come up with our own formulas other than this. So these six parameters, of course, established equations exist. We can automate this whole procedure. But even for other water quality parameters, we can make experiments if there is ground truth data available.
Okay, thank you.
Thank you, sir.
Are there any other queries from the participants? There is one query. Does the nature of relationship between parameters and bands vary from region to region? If not,
Yes, so here,
can,
for example, now we used this formula from France and applied it on Kanpur. And with a few adjustments to the constant values, we found it to work perfectly fine for suspended sediments. But then, how can you be sure? So, everywhere it is compulsory that you have to explore for your own area whether it is correct or not. Because even if I try for 10 more areas, I cannot be sure for the 11th area that this relation can be used. Because here we are talking about quantification. So if I give a parallel example, NDVI value of something does not necessarily mean that it will be a dense tree, or it could be a crop also. So this is the thing. You have to test for your own area. Even you can apply the parameter, but you have to test with your own ground truth whether you are correct or not. And even if the values, but however, here I must mention that the plumes and the gradient that you are getting, that is correct. The only thing that can go wrong is the values. Maybe your value is wrong, but on a scale of 0 to 300, it is going to get rescaled. The error is going to be similar, is constant. So you're going to get your plumes, you're going to get your origins, you're going to get your visualization. That is the thing. And one more, could we import Excel sheet of coordinates with water quality and interpolate for making? Definitely, this is the ideal situation. but you have to check with your institute whether they allow it, because ultimately this goes on the Google server. So our data may not be allowed to upload on the Google server. So you have to check with that first. Otherwise, it is absolutely possible.
Someone asked for showing it for Chilaka Lagoon. I think he works for Chilaka
Chilka.
Development Authority.
Okay, okay. I'll Chilka Lagoon. Right?
Chilka Lake.
Okay, Chilka Lagoon. One moment. Let me just verify the location.
Yeah, I think that's there.
Oh, the big one?
Big one. Just above
Yeah.
Brahmapur. Yeah, that one.
So here we've got a slight problem with images. I'll just do it again. Yes, we can develop and calibrate these relations. Okay, again, we got a slight problem with the image. Sorry, please give me a moment, because yeah, I'll be sharing the script, and about the relations, as long as you have the ground truth data, you can literally do it in Excel. You can have a column where your one column contains all the values for your from your sensors, and the 12 columns in front contain the top of atmospheric reflectance from each band. And then you can set up even a support vector machine. You could run other ML algorithms that you can think of, or you can just do a multiple logistic regression to find out the best ones for predicting this your water quality. I'm sorry, please. I'll do one thing. I'll send across a map. There's being some issue with the cloud-free images. I'll have to alter a script a bit because I'm not getting any image for this area. Maybe if I go, I'll try to go back in time and see if that works out. Yes, yes. Now we have a result. Yes, atmospherically corrected values. Yes, that's why here we have called in the they are already available on the Earth engine. Yeah. So I think here we have some cloud problem. Main thing is to get a cloud free, completely cloud free image. So this script has to be modified a little bit. Our upper limit turned out to be wrong. Yes. Huh. So here now we have the proper concentrations in the Chilka Lake. And again, you can see the patterns. You can see the areas with highest concentration. You can, I mean, you can make a GIS database out of this, that uh, which are the areas with highest, and you can even make graphs and other kind of analysis that are around a year. What is the patterns?
Yeah. Are there any other specific questions? Now, the thing about importing of data containing coordinates and and interpolating for making a map, I think it can be better done in GIS software rather than in
Yes.
Google Earth Engine is not meant for that.
Yes.
And groundwater, I don't know if it is, I don't think remote sensing would be very much helpful.
No, sir.
So someone is asking, it can only give indication about the surface geology, and you may identify the potential groundwater resource zones, but it cannot give you anything more. So are there any other questions? I think Mr. Ramaya, please share the code after doing necessary modifications. We will share with
Modification.
the participants. So
Yes.
if there are no more further questions, they can unmute themselves and they can ask if there is any specific question. Otherwise, we can close this session. Yeah, because you will be getting the code, you yourself can run it for your area of interest. If someone is asking along the coast of Andhra Pradesh, we can do that. And
Okay.
yeah, you would like to show?
Okay. I'll just quickly.
Yeah.
We have a bit.
See, aquifer modeling, it is out of our scope. Actually, aquifer mapping is being undertaken by Central Groundwater Board. Um, we actually it is out of the purview of this course, which is specifically about uh, Google Earth Engine.
Yes. So now here we see something very interesting near Kakinada, that you've got these large plumes. So this is very, I mean, it's all up to experimentation and exploration, that why this has happened, why the values are higher here. So these can, if I lower the thing, I can get an even better estimate of the coastal area. So it is all upon the visualization. So near the river mouth, you can see there's a plume right here. And of course, all of this can be verified on the ground to see how accurate it is being. Yes. And mainly as in modeling, so here the baseline here is that we have to, any large scale study, we can do it on the Earth Engine. And if you want to make your own relations, like sir said, it's better to do it in QGIS or ArcGIS, your own GIS software. You find a relation on one satellite image for one reservoir or one river. And then once you have that relation, then you're free to apply it for a much larger area. You're free to apply it ahead in time. So time and space, you're free to apply it later. But the first experiment, it is highly advisable that you do it in your own system so that you have the definite values. The whatever statistical analysis you do here, you can do it in Excel or any other software. So this is only about pulling a large number of images and analyzing them, which otherwise on even on a powerful system is not possible. So that is what the Earth Engine we can use it.
Okay. Okay, then I think we can conclude this session. Any further queries, you can post it on the WhatsApp group or in the classroom. We will upload the recording of this session later. If someone has unmuted the mic, someone is,
Yes.
yeah.
Yes, sorry to disturb you. This is my question, because you are talking about the Indian river and water sources.
Yes.
But what about the African? And if you want
Yes, yes,
to
sir.
see
Sorry,
for African,
yes, sir. It is possible, sir. It is worldwide. We can the experiments have been conducted worldwide. So
yeah,
but again, like I said, that right now we can try it for Africa also. We can get the plumes, but the values, because for example, if you want to be certain that it is so much milligrams per meter cube, then you need some ground truth. At least from one point, you will need to verify somewhere, because that is again, because on the implementation point of view, that we want to just verify, because this is implementation based, we need to verify it somewhere, but it can be implemented anywhere in the world, sir.
Well, same code I can see if you and I want to see the same code. Same website I can get it?
Yes, sir.
From
Yes, sir.
same.
You can just on the map, you can go to Africa, and
Okay.
then you can just click the polygon and you can run it. Only thing is the
Okay.
a bit large. I mean, the river, it needs to be wider than at least 30-40 meter, because otherwise
Okay.
you
Okay.
just have 4 pixels, 2-3 pixels. The resolution is 10 pixels. So for a very narrow river, it will. I mean, the visualization won't be that effective also.
Okay.
So
Okay. Got it. Yeah. Okay. Okay. Thank you. Thank you very much. Thank you very much. Yeah. Thank you.
Hello, sir.
Yeah, please
Hello.
ask. Yes, Mr. Jagdish Kumar.
Sir, I had doubt regarding this. Actually, you were speaking about like changing the range, like 50 to 500 at once, and then 50 to 130, 50 to 100, like that. So
yes, sir.
the thing is, how tricky it is. Like, for example, if you are giving high range, the entire, these things are changing on the screen. So how to
Yes.
decide that 50 to 130, 50 to 50, or 50 to some broader range?
Yes.
Whether it comes with, we can't go to all the points where we are, seeing this, right? Can you please
Yes.
resolve that thing, sir?
Yes. So basically, this was all for visualization. So that we could get to see the plumes or the higher concentrations. So what I was doing here is I was clicking. I'll just quickly for a moment share the screen again. So in this inspector tab, I was clicking and finding out the approximate range of values that I have already. So for example, if you saw that in the Chilka Lake, I had much higher value. So there I had to keep the the higher value as very large. So here, if we are displaying, so as per your question, so this comes in two parts. That if we are displaying for one single region, then we can do as I did, that we just click it and find the approximate range, and then set the upper limit to that range. So then we can start seeing the higher concentration. But if we are looking at for an entire state, then of course it won't be, even for coastal and deep sea regions, we cannot keep the same range. So there we go back to that geoportal thing, that it needs to be a more refined code, that when the user zooms in, then within that zoom in, within that map. So if I zoom in this much, so within this much, whatever the values are there, so say they should automatically be placed as range. So this kind of an which is that this automation is not too difficult, but it can't be done on Earth Engine as such. It has to be done on the custom portals that will be made, or as such. That I zoom in up to here, so then I should be able to only visualize those values. That I should have the range as the values which are within here. So here now you can see in this tiny little this, I think it's a canal or something. But here you have much higher values. So here my 50 to 130 range is not going to work. So we need to automate it that way if we want to look at large area.
I will
But for
just,
the smaller
I,
area, yes.
yeah, I will just add you can see the custom tab there in the screen which has been shown. You can, I think we have also covered this. It is basically for visualization. You can just as in the QGIS, if you are stretching to cover up to say plus or minus 1 sigma, 2 sigma standard deviation. There are options where you to get some idea about the range, the starting value and the end value for your whatever the map canvas area is showing. Then you can change it manually. Uh, Basically, Mr. Ameya was also doing the same thing using inspector tab, but you yourself can see what is the range by checking on that custom tab, and then you can change the range. Basically, it helps in better visualization. If the range of the actual values is only from 10 to 20, but your display is from 0 to 1000, you won't be able to distinguish the values. So that's what he is doing. He's trying to find the range and changing the values.
Thank you, sir. Thank you. And other things, sir, can we use this GRACE data, sir? GRACE data
Actually,
using this GE?
I don't know whether Grace data is there in the
Like,
Google
to
Earth
know the
Engine.
groundwater levels and all.
No,
Is it
Grace
possible,
data
sir?
also, it doesn't give groundwater level. It only gives the change in gravity because of if there is overdraw of groundwater. So these satellite, the twin satellites, Grace, they will identify change in gravity. So it gives some indication, but the pixel size is very coarse. Like I think around I don't know, it is around 11 kilometers or more than that.
Yeah, very coarse pixels.
It's
And from
very,
an implementation point, it is not very useful.
and Google Earth Engine, I don't know. I don't think it is there. And also it gives, it not just gives about change in gravity due to groundwater, but also all the soil moisture and surface water, everything combinedly, it gives some indication.
Thank you, sir. Thank you.
Okay, then I think we can conclude this session. Are there any other? If there are no other questions in the chat box, we can conclude this, or you can even upload your questions in the WhatsApp group so that our faculty member will have a look and will respond. And we can conclude now. We had 1 hour session. I think it has been fruitful. I'm very grateful to Sri Ameya, our faculty member, and all the participants for joining. Thank you very much.
Thank you.